In this video, we are going to teach you how to solve for derivative of a function by definition and by using basic rules.
So good day, we are the group 8 from CHS1 and the members are Ron James Masangkay, Liz Herbal Alameda, and April Zeus Panoy.
To start with, we are going to solve for the derivative by definition. In this method, we will use the limit process. Using the formula f prime of x is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches to 0. Using this, we can solve for the derivative of a given function. Now let's try an example. The derivative of a function f of x, 4x minus 2, find f prime of 2. Using the formula given, substitute the value of x, which is 2. Now it is f prime of 2 is equal to the limit of f of 2 plus delta x minus f of 2 all over delta x as delta x approaches to 0. But first, we are going to solve the f of 2. F of 2 is equal to 4x minus 2. Substitute 2 to all x's in the function. F of 2 is equal to 4 times 2 minus 2, then solve. 4 times 2 is equal to 8 minus 2 is 6. Next is we are going to solve the f of 2 plus delta x. F of 2 plus delta x is equal to 4x minus 2. Substitute 2 plus delta x to the function. So 4 times the quantity of 2 plus delta x minus 2, and then solve. We are going to distribute 4. So 4 times 2 is 8. 4 times delta x is 4 delta x minus 2. Combine like terms. So 4 delta x plus 6 since 8 minus 2 is 6. Going back to the formula, we can substitute the answers. F prime of 2 is equal to the limit of 4 delta x plus 6 minus 6 all over delta x as delta x approaches to 0. Now 6 minus 6 is 0. We are left over with the limit of 4 delta x all over delta x as delta x approaches to 0. We can now also cancel out the delta x because if we divide delta x by delta x, the answer is 1. So the limit of 4 as delta x approaches to 0 is equal to 4. Since 4 is a constant and there is no delta x remaining in the expression. So the derivative of the function 4x minus 2 is 4. Let's try another example. Find the derivative of a function 4x is equal to 2x squared plus x f prime. Find f prime of x. We can already use the formula as is since we are finding f prime of x. First thing to do is we are going to solve for f of x. This time we are not going to change anything since it is already x. Next, solve for f of x plus delta x is equal to 2x squared plus x. Substitute x plus delta x to the function. So it is 2 times the quantity of x plus delta x squared plus x plus delta x. First thing to do is expand x plus delta x squared. So x squared plus 2x delta x plus delta x squared and copy x plus delta x. Next, we need to distribute 2. Now it is 2x squared plus 4x delta x plus 2 delta x squared plus x plus delta x. Since there is nothing to combine, just arrange it depends on the higher degree. So 2x squared plus 2 delta x squared plus x plus delta x plus 4 delta x. After evaluating the function, we can substitute the answers to the formula. So f prime of x is equal to the limit of 2x squared plus 2 delta x squared plus x plus delta x plus 4x delta x plus times minus the quantity of 2x squared plus x all over delta x as delta x approaches to 0. But first, we are going to distribute the negative sign to the terms enclosed in the parentheses. So negative 2x minus x. With this, we can cancel out 2x squared and x. So we are left over with the limit of 2 delta x squared plus delta x plus 4x delta x all over delta x as delta x approaches to 0. We can also now cancel out the delta x. So the limit of 2 delta x plus 4x plus 1. Since there is nothing to combine or cancel, substitute 0 to delta x since delta x approaches to 0. With this, we can remove 0 from the expression, and now only remaining with the limit of 4x plus 1. So if 4 so if 4 so if f of x is equal to 2x squared plus x, the derivative prime of x is 4x plus 1. I hope you learn and understand how to solve for the derivative of a function by definition. Now we will proceed to the basic rules of derivative. The first rule we will tackle is the constant rule. The constant rule says the derivative of any constant function is always 0. A constant function is a linear function for which the range does not change. It can be represented as if f of x is equal to c, then f prime of x is equal to 0. Alternatively, we can express this as the derivative of c is equal to 0. First example, find the derivative of 10. Since 10 is a constant, its derivative is 0. Second example, find the derivative of pi. Since pi is a mathematical constant, which is approximately equal to 3.14, its derivative is also 0.
So the second basic rule is identity rule. So if f of x is equals to x, then f prime of x is equals to 1. So one example for this basic rule is x dx. So you cannot see any visible constant number beside x, so automatically it has 1 beside it. So as stated, x is equals to 1, so 1 multiplied by itself is equals to 1. So the final answer for this is 1. So for the third basic rule in derivative, it is the power rule. So x raised to n dx is equals to n times x raised to n minus 1. So for the first example, the given is x raised to 4. So the first step is we will bring down the exponent, then copy x raised to 4, then subtract 1 from its exponent. So the final answer will be 4x raised to 3. So another example is x raised to 10. And again, we will bring down the exponent, then we will copy x raised to 10, then subtract 1 from its exponent, so it will be 10x raised to 9.
So for constant multiple rule, let C be a constant. C times f of x dx equals C f prime of x, or the constant times the derivative of a function. For example, 6x squared dx. So 6, which is the constant, times the derivative of x squared. So we will use power rule here. What we're gonna do is bring down the exponent of 2 times x raised to 2 minus 1. So 6 times 2x squared minus 1 is 12x. That's the answer. Another example, 13x raised to 6 dx. 13 times, again, apply power rule to get 6x raised to 6 minus 1. So 13 times 6x raised to 6 and minus 1 to the exponent 6 is equals to 78x raised to 5. That's the answer. But for the addition subtraction rule, the quantity of f of x plus or minus g of x is equal to the derivative of f of x or the first function plus or minus it based on the sign of the derivative of g of x or the second function. For example, the quantity of 2x plus 4 dx. First thing you're gonna do is to find the derivative of each term or function. For 2x, x is a power of 1, so you're bringing it down and multiply it to 2. Plus 0 because 4 is a constant, so it will be just 0. So 2 times 1 plus 0 is equals to 2. That's the answer. For example number 2, 5x squared minus 3x plus 6 dx. So 5 times 2x raised to 2 according to power rule. After bringing down the power down, you must minus it by 1. Minus the second term 3 times 1 after applying constant multiple rule, plus the third term 0, which if you apply constant rule, it will be just 0. So 5 times 2x squared minus 1 to the exponent is equals to 10x, and you don't have to write the 1 above the x. Minus 3 times 1 equals negative 3 plus 0 equals 10x minus 0. Or again, 10x minus 3. So for basic rule number 6, product rule, f of x times g of x dx equals f of x or the first function times the derivative of the function g of x or the second function plus the derivative of f of x times g of x. Alternatively, we can express this as u v dx equals u dv plus v du, where u is the first function and v is the second function. For example, the quantity of 2x minus 7 times the quantity of 8x minus 5 dx. First thing you're gonna do is to copy the first function, 2x minus 7, times the derivative of the second function, 8, plus, just copy the second function, 8x minus 5, times the derivative of the first function, 2x minus 7, which is 2. So 2x times 8 equals to 16x. Then 7 times 8, negative 7 times 8 is equals to negative 15x, 56. Then 8x times 2 equals 16x. The negative 5 times 2 is negative 10. Then combine like terms. 16 plus 16 is equals to 32x. Then the constant or which no there's no x. Negative 56 minus 10 equals negative 66. The answer 32x minus 66. For the second example, the quantity of 4x squared minus 6x plus 1 times the quantity of 9x plus 7 dx. First thing you're gonna do again, copy the first term, then times the derivative of the second term, plus copy the second function, 9x plus 7, times the derivative of the first function, 8x minus 6. Then again, 4x squared times 9 is equals to 36x squared. Then negative 6x times 9 is equals to negative 54x. Then 1 plus times 9 is equals to 9 plus 9x times 8x is equals to 72x times 9x minus 6 times 6 negative 6 again 9x times negative 6 is equals to negative 54x. Then 7 times 8x is equals to 56x. Then combine like terms. I, again, the last in the FOIL method is the last 7 times negative 6 is equals to negative 42. Then now to the combine like terms. 36x squared plus 72x squared is equals to 108x squared. Then negative 54x minus negative 54x plus 56x is equal to negative 52x. Then 9 minus 42 is equals to negative 33. And we got the answer 108x squared minus 52x minus 33.
Now for the quotient rule. The quotient rule states that the derivative of a quotient can be solved by following this. The denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. It can be expressed as low d high minus high d low all over low squared. Let's give an example. Find the derivative of 2x squared plus 4x plus 3 all over 5x minus 2. First, copy the denominator times the derivative of numerator, which is 4x plus 4. Then minus, copy the numerator multiplied by the derivative of the denominator, which is 5, all over the quantity of 5x minus 2 squared. Then solve. We can use the FOIL method in 5x minus 2 times 4x plus 4. So 5x times 4x is 20x squared plus 5x times 4, 20x. Negative 2 times 4x is negative 8x. Negative 2 times 4 is negative 8 minus, so we are going to distribute 5. 5 times 2x squared is 10x squared. 5 times 4x is 20x. And 5 times 3 is 15. All over the quantity of 5x minus 2 squared. Before combining like terms, we need to distribute the negative sign. So negative 10x squared minus 20x minus 15 all over the quantity of 5x minus 2 squared. Then combine like terms. 20x squared minus 10x squared is 10x squared. 20x minus 8x minus 20x is negative 8x. Then negative 8 minus 15 is negative 23 all over the quantity of 5x minus 2 squared. Since there is nothing to do, this is the final answer. Another example, find the derivative of 2x squared minus 12x plus 18 all over the quantity of x minus 3. Again, first, copy the denominator multiplied by the derivative of denominator, which is 4x minus 12. Then minus, copy the numerator multiplied by the derivative of denominator, which is 1, so we don't need to put it. All over the quantity of x minus 3 squared. And then solve. We can use the FOIL method in x minus 3 times 4x minus 12 So x times 4x is 4x squared. X times negative 12 is negative 12x. Then negative 3 times 4x is negative 12x. And negative 3 times negative 12 is 36. Then distribute the negative sign. So minus 2x squared plus 12x minus 18 all over the quantity of x minus 3 squared. Combine like terms. 4x squared minus 2x squared is 2x squared. Negative 12x minus 12x plus 12x is negative 12x. Then 36 minus 18 is 18 all over the quantity of x minus 3 squared. In the numerator, we can bring out 2. Now it is 2 times the quantity of x squared minus 6x plus 9 all over the quantity of x minus 3 squared. X squared minus 6x plus 9 is a perfect square trinomial. So it can be factored to a quantity of x minus 3 squared. Now it can be cancelled. We are now left over with 2, which we can do nothing about it, so it is the final answer.
So the last basic rule in derivative is chain rule. The derivative of f of g of x is equals to f prime of g of x times g prime of x. So example number 1 is the quantity of x minus 7 raised to 6. The first step is to find the value of u. So our u here is x minus 7. Then to get the derivative of u, we should get the derivative of u to get the du. So what is the derivative of our u? So x minus 7 is equivalent to 1 because from the identity rule, x dx is equals to 1. Then negative 7 from the constant rule is equals to 0. Then we will substitute the value to u du. So our u has an exponent of 6. Now, from the power rule, we will bring the exponent down, then copy u raised to 6, then subtract the exponent to 1 times du. Now, if we subtract it, it will be 6u raised to 5. Then again, we will substitute the value of u, which is x minus 7. So it will be 6 times x minus 7 raised to 5 times the derivative of u, which is 1. To simplify, we will multiply 1 to 6, so the final answer will be 6 times x minus 7 raised to 5. So another example is the quantity of 2x minus 3 raised to 4. Again, we will find first the value of u and the derivative of u. So here our u is 2x minus 3, and the derivative of u is 2. So how did we get it? So as stated into the identity rule, x is equals to 1. So 2 times 1 is equals to 2. Then the negative 3 from the constant rule is 0. So our derivative is 2. Now again, we will substitute the value to u du. So our u has an exponent of 4. So from the power rule, we will bring the exponent down. So it will be 4. Then copy u raised to 4. Then subtract 1 from the exponent. So it will be 4u cubed times du. Now we will substitute again the value of u and du, which is 4 times 2x minus 3 cubed times the derivative of u, which is 2. To simplify, we will multiply 4 times 2. So the final answer will be 8 times 2x minus 3 cubed. So that's all for this tutorial video. And once again, we are the group 8 from CHS1.